Welcome, everybody. Please come in and find a seat. Remember to switch your phones off. I'm looking for the emergency exits. You should do the same. I think that's behind us here. And then the entrance. I cannot see so well. I think this is the 3 emergency exits. We will not use them, I suspect. But just be prepared. And then I would like to welcome you all to this round table, as you can see. You are not in a round table, but that is also not a good thing with a round table, because then we will all be sitting, some of us, with them back to you. So really we try to face you, because we want to involve you. We want you to ask us important questions, to guide us, where are the problems. We will go through the we have 5 key questions, but we want you to engage. This is not going to be all of us lecturing. Can you hear me? No. Better now? Well, thank you. So really, we want you to be part of this meeting, not just us up here. So I will start very unmodest to introduce myself, to give the other people a model for how to do it. My name is Per Kryger. I work at the University of Aarhus here in Denmark. I've been working with bees since '83. You can do the calculations, a long time. I have been working in Africa, in Germany, now I'm in Denmark, taking care of keeping the bees in Denmark healthy. So that is my job, and of course I have a key interest to be present here today. I think that's what I want to say for now.
Can I just break in? Please have a seat, everyone. We're not allowed to use the stairs to sit or stand. Everybody must sit. There are seats around. So please use the seats and don't stand in the aisles or on the stairs.
And the chairs are for people, not for baggage. So please remove your bags.
Okay, so I proceed. My name is Büchler. I have the pleasure to share the obligation for this roundtable discussion with Per. I am the former head of the Bee Institute in Kirchhain, which is very much dedicated to bee breeding, bee genetics, but also biotechnical methods in management, and this was core of my research activities. Now I'm retired since about 3 years. Happy to stay still active in the field and exchange knowledge, exchange with talks, with publications, with project involvement. But maybe more important, I'm also enthusiastic beekeeper since my childhood, 50 years now, and since I'm retired, I increased the number of colonies. I'm a registered breeder, do all the selection work, data collection, and so on. I'm very happy to say that since 10 years I have no further chemical treatment on my hives, combining good genetics with certain management techniques, and I think this is what we will focus on for the discussion. So this is the two. We share the session, but now we want to have a short introduction of all panel partners. Thank you all for coming here. We selected you to have a good representation of science on one side. We want to hear what is the recent status of bee research on resistance, but at the same time to have beekeepers, small-scale, large-scale beekeepers, and also representatives from associations and from the advisory service. So this is how it is together, and we will see step by step. Maybe we can start on the left. Fanny Mondet, please. Keep it short, but...
I'm Fanny Mondet. I'm a bee biologist in France, the National Institute for Agronomy Research, and I work mainly on varroa mites and interactions between bees and mites, and trying to understand why bees can cope with mites under certain circumstances.
Thank you. I'm Steve Riley. I wrote the Honeybee Solution to Varroa. I represent a club in the southeast of England. We have about 130 colonies now not being treated or the mites reduced in any way. And this is our 8th season, so we're happy to share practical ideas on how other beekeepers can get there.
I'm Stefan Mandl. I've been doing Varroa research for nearly 40 years now. Very fortunate to travel most of the world and looking at resistant stocks in Brazil, Cuba, South America, many countries. So Varroa's been my life effectively. I'm now retired like Ralph and doing social change, trying to convince beekeepers that the bees have the answer.
Thank you. I'm Barbara Locke, and I'm Associate Professor and Director of the Honeybee Research Center at the Swedish University of Agricultural Sciences in Uppsala. I work with disease ecology and ecoevolutionary dynamics between honeybees, mites, and viruses. I'm also a beekeeper. Have around 40 hives at home and have been working with bees in one way or another for over 25 years.
Hi, good morning. I'm Steve Pernal. I work in Canada for our federal government in the province of Alberta. Most of my career I've worked with honeybee diseases and pests, especially Varroa. And I've had some projects looking at the development of novel markers for the selection of better queens. Currently, I work with this guy a little bit, with Pierre, and in Canada we're trying to develop better strategies for beekeepers in Canada to breed and actually winter their own queens. So I guess part of my career has been in the promotion of queen breeding and development methods of selection.
Hello, my name is Pierre Giovenazzo. I'm from Canada, and my passion is breeding bees. So I'm professor at University Laval in Quebec. That's the eastern part of Canada. We've been breeding bees at my university with colleagues since 2009. And by the way, we imported in 2009 50 Danish queens from Kjeld. So we started with that. So that's what we do. So a couple of successes I can say that maybe this will initiate something. I think we successfully, since the past 15 years, successfully produced queens that build up spring rapidly, winter nice, are nice and smooth. But the things that we did not succeed is to select for Varroa resistance. Sorry to say that, but that's our challenge now, yeah, for many years.
Okay. Hello, my name is Johann Fischer. I'm a member from the Institute for Bee Research and Beekeeping in Bavaria, Germany, and I'm a beekeeping advisor. And I'm advised that beginners beekeeping, but also the bee breeders, and for myself, I breed also with Varroa resistance and select queens and works with the bee breeders. Thanks.
Hello, my name is Torsten Ellmann. I'm the president of the Beekeepers Association from Germany. We are part of the Varroa 2033 project in Germany, which are used it's founded by associations of beekeepers from Germany. We have the Backfast dark bees and Carnica and all they are in the project, and we will have treatment-free beekeeping to 2033.
My name is Stefan Mandl from Austria. I'm a beekeeper there. We make organic honey production with about 800 bee yards. And with about 2,000 colonies each year, we make performance testing. And with these colonies, about 37% are already treatment-free. So it's possible to go with performance testing and selection and controlled mating to become a treatment-free beekeeper.
So thank you everybody for a very quick lightning round almost. So we will start with the first question that we want to debate with you. So what are the traits involved in Varroa resistance? I would like to pose the question to Fanny, because you have worked a lot with this.
This has been studied extensively now by several of us here and many people in the world. So we know that there are several traits involved in honeybee resistance or tolerance, because there are two different things. And possibly, I mean, we can breed for one trait in particular, but when we look at populations that survive naturally and we try to dig into them in a bit more details and we look at why they manage to survive despite having mites without treatment, we usually find several reasons identified for this. So there is the ability of bees to detect the presence of mites within the hive, and so they will clean these areas. So this can be through grooming, for instance, when they detect it on adult bees and they do it themselves or to other nestmates in the colonies. And then another behavior called hygienic behavior, in a general sense, they will detect that the mites are in the brood. So as you know, the mite reproduces in the brood, so they will detect that something is wrong there and clean the content of the cell, and as a result, these mites will not produce offspring, so there will be less mites produced in the colonies, and so the mite population will be reduced as a result. Another mechanism also that is a bit less characterized, but we know exists, is the ability of the brood itself to disrupt the reproduction of the mite within the brood cell. And the result is the same, that the mite population growth will be reduced. And then there are other aspects more linked to at the colony level. For instance, we know that when bees swarm, that will also affect the mite population, and overall the population dynamic within the colony and the dynamic of the brood and of the bee inside the colony will also affect the dynamic of the mite, because it relies on the brood to reproduce.
We have follow-up questions. So, how did you find those bees to do that work on, to find those traits?
Okay. Yeah, I mean, I can talk about the Gotland population. I'll also talk about it.
Scandinavia.
Yeah, we are in Scandinavia. If you don't know where Gotland is, it's a little island in the Baltic Sea. It's not a little island; it's a big island. And it's a really nice island. There's a lot of beekeepers there that aren't having resistant bees, but there is a small little experiment that was set up by my previous supervisor, Ingemar Fries, in 1999, and he wanted to do a natural selection experiment, and he brought colonies from the mainland Sweden with a wide genetic variabilities to have lots of genetic variation. And then they were isolated on a peninsula in the southern tip. And the idea originally actually was to let them swarm freely, and he was really interested in using evolutionary biology to understand the dynamics here. And so he wanted to, his hypothesis was that, like with virulence theory, that if you have a vertical transmission where the parasite needs the host to stay alive and transmit to offspring rather than just horizontally killing the colony and spreading to the next bee. So if colonies were swarming more, then the mite would perhaps be less virulent and adapt to be less harmful for the colonies. But they didn't swarm more because the mite was too dangerous and killed 85–90% of the colonies, and a few survived. And then we started to examine how they're surviving, and we saw that it was very clearly a trait of the honeybees. Even when we moved bee queens from this population, they still were able to reduce the mite population growth. And we found that when we looked closer, the mites were not reproducing in these colonies. So that was like the big thing, that they're not reproducing, which is not weird. We've also seen that in other populations in Africa, and that mites don't reproduce as well. But then we started also to try to understand deeper why the bees are, how the bees are able to affect the micro reproduction. And then of course we have all the great work on VSH that Fanny has done, and yeah, I think I'm a little more interested in the brood side of things, and and we have some talks tomorrow more on that as well. But I think that the bottom line is that we see there's a reduced reproduction, and then how is that happening? Is it by adult bees doing something that causes the mites to not reproduce? Is it the brood doing something that causes the mites not to reproduce? And that's the, like, I think a key trait that we see in a lot of populations is this low mite reproduction. But even though also Fanny mentioned that you have this very specific trait at the individual bee level, but as a colony, it doesn't always mean that you have these super resistant colonies, because they can still have quite high mite infestation, even though they're able to reproduce or to reduce the mite reproduction. Yeah.
So you talk about a trait. I'm a geneticist, so maybe I will ask Pierre, is that trait that you are using in your selection program?
So this is a challenging question, you know, because when we have this program where we want to breed bees, traits, phenotypic traits are really important to do the selection process. We have tried to use non-mite reproduction as a trait, but the thing is how do we incorporate this in a schedule of reading, in a reading program? Sometimes, and a lot of times, we discuss about this, and I say to myself, why not just select for honey production? A colony that produces honey is a good colony. And, you know, we've been trying with Ralph and Per and our group to find, and Fanny, and to find a trait that is linked to the varroa production, to the varroa reproductive cycle. And that is a big challenge. And I really don't know how to do it. And if we would, you would already have the bees. You know, this is something. So we're trying new stuff. So we're trying to introduce now genomics in our breeding program with SNPs or genomic traits from the genome that will identify these behaviors that are complex, like Fanny mentioned. So that's it. So the traits. Yeah, so I sent you the question, so why not just do honey production? So that's the question I always ask myself every year. But I don't, you know, we do more than that, but yeah. Well, I don't know, yeah.
Not so easy to get these traits tested on a large scale, and you mentioned now that markers, genetic markers may be helpful. What is the stage of development? And I think also you, Steve, did important work in this field. Maybe you can give us an idea. Is there a chance to use these markers in future?
You know, I think there's certainly potential there. I mean, I have been involved in marker projects, and sometimes the repeatability of success using a marker panel you've developed is not always as great as you might have hoped. I think with the advancement of genetic techniques, I think there is certainly potential to do that. But I think what Pierre is also relating to is just the infrastructure necessary for the selection of queens and doing that within a breeding system. So how do we do that? So I think for specialized breeders, there may be a way of doing that. I think for programs in which you have the infrastructure, perhaps through a university or a government extension capacity, you can do that. Is that something that's going to be readily available to every beekeeper out there? Probably not. So perhaps those markers would be useful in the dissemination of very selected breeder queens that could go into the industry. So I think genomic tools are going to play a role in the future, but I think we have to think carefully about how they can be incorporated to develop stock for the industry. I think the other broader question about selection in Canada and the US, and I was talking to some of these gentlemen previously, is Europe and North America are very different paradigms in terms of queens. So if I look at my colleagues in the US, many of you know, most of the queen production is centralized with a small number of queen producers that disseminate thousands and thousands of queens. And in Canada, we're very dependent on importation of stock. So one thing that we're looking at in Canada, Pierre and I and others, is the promotion of more queen breeding, and actually ways in a cold northern climate in which we can produce queens late in the season and carry them through the winter. So Pierre's group has been very instrumental in wintering queens, and we hope by these techniques, at least Canada can become more self-sufficient in producing queens, and then I hope from that we can get better actually at the selection of stock. But the beekeepers I know that are successful in breeding their own queens may not have sophisticated selection techniques, but they breed from survivors. As I say, the best selection event we have is winter. So the most dramatic one, so breeding off your survivors and breeding off your good producing colonies. And simply by using that selection, I see a lot of our producers being very successful and self-sufficient in Canada and not having to buy queens in a North American context. That's quite a significant paradigm shift from what how most beekeeping is done.
Yeah, thank you very much. I think at that point we can step a little bit back. We are already in the breeding program, but I mean, we know there are resistant populations nowadays throughout the world and on all continents. And one who did huge studies on this is Stefan Mandl. And Stephen, I would like to ask you, what can you share with us from your experience on how resistance can develop under natural conditions?
Remove the beekeepers from the problem.
We did that as well.
Yeah, so I've been very fortunate to travel the world, so I've seen beekeeping all over the world. And what I've come to realize is that you must think globally, but act locally. Everybody tends to look at their own situation and think that's what everybody else does. And real realization, this was very recently, I was in China, we were writing some work up and they said, you know, we run a 2-queen system like everybody else in the world. And I thought, hang on, I've never heard of a 2-queen system. And then it really dawned on me. So I've been looking at resistant bees since the 1990s. I was fortunate to work in Mexico, where Africanized bees were naturally resistant. And we're trying to work out the mechanism, and that's taken us a very long time. So there are huge swathes, the whole of Latin America, anywhere there's Africanized bees, Caribbean, where they have a mix of European and Africanized, or Spanish European, the whole of Africa. In fact, all the countries that didn't go down the treatment route, didn't use treatments because of cost, accessibility, and just let their bees go, they've all now, after a period of time, got resistance developed. And we see the same traits, those that Fanny's already mentioned. The bees' their ability to detect the infested cells, remove a high proportion of these, and increasing the infertility of the mite to the left. So the only people that really haven't is the people who are stuck in the treatment cycle. And I think Steve Riley will talk nicely about this sort of 2 phases. You're either in the treatment cycle or you're in a non-treatment cycle. And you know, that's the 2 stable situations. But yeah, it's the beekeepers at the end of the day. Because if you're locked into a treatment cycle, it's very difficult to get out of. We now know, which is great, that resistant bees are in every country, in every environment. From South Africa, you know, right in the south, right up into North Norway. So it's not, and it's nothing to do with the type of bee. It's Carnica buckfast, you know, mellifera, whatever. It's the bees themselves that could do that. We just beekeepers need to help them transition from one to the other. The bees can solve the problem. They have been around for hundreds of millions of years, and they've lived really well without us. And they've dealt with all these diseases in the past. And they've got these beautifully complex mechanisms of things like hygienic behavior to deal with all sorts of things. And they will deal with tropical apse, and they can deal with varroa. We need to help and understand them. Our job as scientists is trying to find out the beautiful complexities of how that works, to try and convince you as beekeepers that actually just trust your bees and they, you know, let them get on and do what they do really well. And rather, we often try and think about helping them too much, to be honest. We can solve their problems. Actually, they need a bit of help from us because the way that we manage them. But they have the solution, so we really need to learn from the bees and not the other way around.
Yeah. Thank you very much. Very stimulating. Great perspective. I guess the beekeeper won't stop beekeeping in the room. So, but you already mentioned Steve Riley as a partner and colleague who found a way out of this treatment cycle, and you wrote an interesting book. Many of us probably know it already, but Steve, now we are here, and we are really happy to hear. What is your experience? How could you develop those things on your small-scale beekeeping level?
We did start small scale, but what we're doing is scalable to every beekeeper, everywhere where there's a grower. Perhaps not Australia at the moment, but it will be the case in a few more years. So it is scalable, and it's not using specialist bee breeders, which can be a bit of a challenge amongst perhaps some of my colleagues on the desk here. So we've tried to understand from following the research from some of the greats I'm sharing a table with here, and also from the work that USDA did, led by particularly Dr. John Harbaugh, and just to understand what the traits were that naturally surviving bees. And then we try to work out how we could observe these traits. And so I think if you go back to what nature is doing, you have a long-term sustainable solution. And so we look for things like uncapping at the pink to purple-eyed stage, which you tend to see in clusters, and which is the search phase for what the bees think there's a problem. Either there's an infected pupa or a grower family there. There's some great work by Fanny Mondet's team on that, which we follow pretty closely. The next phase is the bees actually removing the pupa, and in doing so, stopping the sons and daughters of mites from reproducing. So you don't get that massive reproductive growth in mites, which you see in a lot of colonies. And at the same time, all of those young mites are not going to survive. They're soft-bodied. And so you've killed a whole generation there, and at the same time, a future generation. The mother mite will typically escape, but she's used up one of her 2 to 3 reproduction opportunities. And for us, this is very easy to monitor. So we've integrated uncapping and looking for uncapping as part of our hive record cards. We teach this at our training apiary, so we have first and second year beekeepers who understand what to look for. We also then, because we were looking at mites on board, board underneath open mesh floors, we started to see in the early days bits of chewed out pupa at the pink to purple eye stage, which we came to understand this was the follow-through. You typically see the antennae and bits of the proboscis and thorax, not often abdomens, but you could actually see that this chewing out process was going on. We could see the follow-through. And then at the same time, when we're looking at these boards, where there's a huge amount of information, you can see the number of mites and follow through. And in fact, the mite count gives you a much clearer and more confident idea of what's going on because you're able to see the other traits being carried out. And that's the process that we've used now for a while, the selection process. If there's more going on then we don't use it. There may well be some extra wrinkles in the system which we don't understand with beekeepers we can't follow, but that does seem enough. And our selection process is just rolled out through the club. And there are a lot of other clubs now in the UK which are following this. So we'll see how that works, and so far so good.
So thank you very much. So Steve, you actually make it sound not so complicated.
The complex stuff, I think, is for you guys, okay, to work out. For the scientists, and the genetics, I think, in particular, is very difficult. But the phenotypic traits driven by those genetics are things which we can all see, observe, and monitor for. And I think that's, that's the key point to try and get over here, that everyone can do this.
So actually, there's two key messages here. We cannot legally take out all the beekeepers. Laws against that. But let the bees have more space and to evolve this trait by natural selection.
Well, we're not letting things go, actually, Per. So the monitoring will tell you which bees have the ability with grower and which ones do not. And so, very simply, you're going to breed from those with the lower mite counts where you're seeing the traits which you're monitoring for, and you're going to requeen the rest. And if you find this out late summer, and it's too late to requeen at that stage, then either treat or use queen frame trapping, one of Ralph's ideas, and then requeen those the next spring. So you have this sort of rolling program of getting rid of those colonies which are non-resistant. So non-resistant bees are producing masses of mites and associated levels of deformed wing virus. And you do not want those near your other bees. And we certainly don't want to be buying them from bee suppliers.
So maybe now we also want to make sure that the audience feels involved. So do you believe that it's simple and easy and you just have to step back, or are you skeptical? What can we do to change the mood in the beekeeping community? We have people here who have already changed, but we have a lot of people who are curious. How can we get you from getting curious to getting involved?
I see that there's hands up, but there's actually microphones set up, so you should go and line up at a microphone if you have a question. No? Oh, okay. Förlåt.
Please stay on your seat.
Forget that. We've been doing that in the other rooms. Sorry. I wanted to just, from my experience, and I'm not a geneticist, and I haven't been around in Africa and seeing all these other populations, and I haven't really tried it myself to do this kind of selection experiments. But I just want to note that from what we see in our population that's not being treated, they have really high mite infestation pressure. They're not doing well. They're not a colony that I would want to keep because they're very sick. They're very susceptible to other kinds of diseases. They're full of chalk brood, and that's genetic because even when we move the colonies to other countries, they still are highly susceptible to chalk brood. So I think it isn't so easy to just say stop treating. And I mean, I respect a lot what you're doing, but I don't think it's so easy just to do this. And also the traits that you're describing to characterize, they're really highly complex. And in Sweden we have super engaged beekeepers, and we've tried to do this on a national level to get beekeepers involved in trying to select and identify and select these traits. And it's so difficult to really select these really specific traits. And then I wanted to also add, I'm sorry, I'm also Canadian, so just to add, but I really like what you said too, because you brought up a very important question: why? Why are we so focused on not treating our bees? Maybe our focus should be having healthy bees. I don't know. I'm throwing this out there for you guys. I think that the treatment-free bees that I work with, they hurt me. They hurt me to see them so sick. And the ones I have at home that I take care of, and they have beautiful brood patterns, and they're gentle, and those are the bees that I like. So I think we also need to think about why we're doing it, what's our responsibilities to bees. They can survive and adapt naturally traits and such, but I mean, a lot of the environmental issues that they face are from beekeepers. Not only just the way we manage bees, but also we introduce these diseases. So that's what I wanted to throw out there.
Okay. So where did the microphone disappear? Please stand up.
Yes, okay, Even from Oslo in Norway. I would just support those two gentlemen. It is easy. It is just a case of selecting for few varromites. When you have, well, our thought is that when you have a lot of different traits interacting, and you don't know exactly how to go to select for each specific, select for the simple thing. Count the number of varroa. Simply include it as part of your breeding program. You want nice bees, you want them to make honey, and you want the mite number to be low. You can have equal weight on each of them, but as long as for every generation you work with those that have the least number of aromites, you get there in the end. I say it's easy, but it's time consuming. It takes many generations. But in the end, you get there. And we have a community, we haven't treated them for a human generation, 25 years. And we have gentle bees, we then make normal amount of honey. We have put them in different places, but we always keep breeding, counting the varroa. So, my question to these two gentlemen, are there any bee stocks in the world which you do think will not be able to develop varroa resistance if given the possibility by the beekeepers?
No.
We have one up here.
Yes, we have a question up there. We also have
Thank you.
one in the first row.
I'm interested in, there was a, sorry?
Go ahead.
Earlier there was the comment about just selecting for the most honey. From reading Steve Riley's book, there is, when the bees are really busy on the nectar, they'll be less hygienic. Therefore, to extrapolate from that, bees that are hygienic and varroa resistant will probably produce less honey. But could you comment on that?
So the most productive bees I've ever seen in the world are from Cuba. That's solely down to the amount of forage they've got there. They're palm forests. They have an unlimited amount of nectar. They have 220,000 colonies. Their average per colony is 70 kilos. That's for all colonies. Some colonies are much higher than that, at 100. And they're varroa resistant as well. This is an anathema. This has been often talked about. Yes, it's true that when there's a large honey flow on, then bees will not do all the tasks. But this doesn't last for months. It only lasts for a short period of time. Most of the countries which have got hygienic colonies, so Africa, Latin America, their honey production has increased dramatically over the last sort of decades. The countries where it hasn't, places like North America, where treatment is widespread. No, in my experience, resistant colonies are just as productive as non-resistant colonies or treated colonies.
Just a couple of points.
I don't know if it's, oh, it's on. Thank you for that. I'm Natalie B with Be Mindful, and I believe that a bee that relies on chemical to survive is not a bee I want to keep. It's not a bee worth keeping in my book. I just came back from, first of all, there's a couple of things I wanted to ask or differentiate. There's commercial beekeeping and there's backyard beekeeping. The vast majority of us are backyard beekeepers that have the luxury to look into survivor stock, because we're not relying on it for business and income. So we have the option to do that. The treatment-free, I keep 400 colonies completely treatment-free, and my bees are thriving. They're beautiful because I selected at the animal level, and I let them do their thing. And like Dr. Stephen mentioned, natural selection will pick the best bees because their nature selects for fitness, selects for reproduction, and they cannot do that if they're not thriving. The other thing, my question really is, I just came back from Australia, where they just got the incursion of the mites, and I was speaking at Natural Beekeeping Summit, and all up and down the eastern coast of Australia, and it appears that their concentration of colonies is much higher than anywhere else in the world, a little bit like Stephen Martin mentioned, and a bit coupled with high level of forage, it appears that they might actually go through the natural selection a lot faster than in other countries where it takes 5, 6, 7 years. They're hoping that in 3, 4, 5 years, that natural selection will take place, and those survivors will help reinforcing the commercial stock. So the backyard beekeepers are creating clusters to help each other, a little bit according to Stephen Riley's work, where they're helping each other with resistant genetics and spreading and requeening, which is a little bit less natural selection than pure survival of the fittest. But I wanted to know from the ones that have studied this extensively, if you think that in Australia, they're going to indeed reach that level of survivor stock and stability in the wild bees a lot faster.
Time will tell. The proof of the pudding is in the eating. So we'll have to wait and see. It's true what you said. They have a large amount of wild or feral bees in Australia, and they have very rich forest because of the eucalyptus trees. And I think if they just stop nuking the hives that they find mites in, then they will get there very quick. But if they keep on killing all the bees that have mites, they will end up without bees.
Okay, we have one here.
Yes, like Stephen Martin said, and John Kefus over there has said before, the real problem is the beekeeper and remove the beekeeper. And that's been done. The easy part is making a varroa-resistant bee. It's the easy part. The difficult part is how we distribute these genes to all beekeepers. And I think every beekeeper shouldn't start from the zero. We should use these varroa-resistant stocks. And we are not losing our bees if we are making these crosses. We are just moving the genes. So I think the solution is, like the previous said, that we should start with doing little circles, little beekeeper groups, stopping treatments in little circles, and then these little circles grow bigger, and so after 10 years the problem is solved.
We have 3 more here.
Yeah. We also have a question, very early question here on the front row. Nuno is also there. Yeah.
Hey, I wanted to do some points and then do a very practical question. A colony will not develop resistance. Like, if the colony is not resistant, it will die, and that's it. And that's what it is. We are talking that we should remove the beekeeper. I don't think we should just remove the beekeeper. We should do what we're doing. We should give tools to the beekeeper for the beekeeper to do the selection and to know which colonies it should select. So from a practical point of view, how many colonies should we start to do this selection? 100 colonies? 1,000? 10,000 colonies? Like, how many percentage of colonies do you believe that have resistance rates? Hey, thank you.
Probably many different answers to that along this road. We started small, okay, so we were nervous when we first started the project, and we put at the starter group with 28 colonies got involved, and which second year grew, we put all our colonies in, which is 40 something, and so it's grown from there. So we've started small, looked for the traits, and then bred from the ones which had those abilities with Roa, and then deselected those which did not. Randy Oliver, you may be following his project on the west coast of USA, has, I can't remember the exact number, 1,000, I think it is. 2,000. And he will argue, I mean, he's commercial, okay, so he's selling his, what they call golden Westies, which are row-resistant queens now, and trying to convince the other commercial beekeepers that they need to do the same. And he will argue we need a lot. It seems if you look at, just look along the row here, if you look at what happens when Varroa first arrives, it does seem that about 10% of Varroa naive bees have the innate ability already to cope with Varroa mites. So it seems to be out there in all populations and just needs looking, and that's at the start. So in Australia, you know, they probably have 10% at the start when mites first arrived. I suspect it's probably similar with us as well, and possibly in Gotland as well, where they had an interesting experiment. And we're now 30 to 40 years on, so that number will be higher. The problem is the mass production of non-resistant queens and selling those to beekeepers, whether it's in the UK or any other country around Europe or North America. And that's holding back. At the same time, we haven't known how to select for Varroa-resistant traits, but we do now. So people can accelerate the process quite quickly by requeening and just getting rid of those colonies that cannot cope with Varroa. And I think with knowledge, when we look back at our process, if we had the knowledge we had now, right at the start of the project, we could have done it in 3 years. And if you talk to people, and this is with open mating, okay, if you talk to people with using instrumental insemination, and the people who first really found VSH in the USDA, they would say they could do it in 2 months. I'm not quite so sure about that, but I think 2 months on one colony perhaps, but I suspect the time periods are probably about the same. So two key things there is stop selling or buying non-resistant queens and nukes, and start selecting for Varroa-resistant traits.
I think we'll take one last question from the front row here, because we were very early to mark.
Thank you. My name is David Peck. I did my doctoral dissertation with Tom Seeley at Cornell, studying the Varroa-resistant Arnott forest population there. And I say that just to say I know how tedious it is to go through a colony and try to characterize the mite-resistance traits that it does or doesn't have. And I know many of the people on the panel certainly have done the same. So I have a very specific question for each of the panelists, which is, we've had the suggestion made, and some here have already put forward the idea that we don't need to know how a colony is resistant to mites, we simply need to know whether it expresses sufficient resistance to have low mite population or not. We've also talked about the subtle differences between these different traits, and the fact that naturally selected resistant populations have a suite of traits, and not just any one particular silver bullet trait that solves all problems with Varroa. So I wonder if each of the panelists might comment on whether a beekeeper sitting, listening to this discussion or reading the results of this work should be planning a breeding program which uses as its only metric the total number of mites found in a colony at an assessment point when they're making their selection decisions? Or is there some danger in not doing the unbelievably tedious and laborious work of trying to characterize the grooming traits and the suppression of mite resistance and the VSH traits? Is there value in doing those assays, or is that more a curiosity for scientists to waste their time with? Should the beekeepers be ignoring those specifics and just saying, these colonies have mites, these colonies don't, so I will breed from these and not from those?
I dare to start. I was working in Africa when the Varroa mites arrived. Nobody did anything, and nobody lost bees. They lost bees for other reasons, but not because of Varroa mites. I'm sure some colonies were lost, but the bees were reproducing so fast that nobody noticed the loss. So it is, the traits are there, they're just waiting to be picked up. And if we keep on intervening with chemicals, we can sit and wait forever.
Can I say something too? I don't think that beekeepers should be spending their time looking at these traits. But I mean, basically, yeah, to really do this well, you need to invest the time and still do a lot of monitoring. And so I think it is, like you said, time consuming to do it. It's possible, but very time consuming. And that, I think, is a difference between just stop treating and they will become resistant and perfect. I think you need to invest a lot of energy and still have a program, but maybe not based on these detailed trait assessments.
I would like to contribute from the experience in Germany and neighbor countries. There's quite a number of groups in the meantime which go for this SMR testing with one drone in simulated green, so following the Harbour model. And we see some success in this. So it's an enormous load of work. It engaged people, so there are beekeepers who like to join such group and they learn, so there is a good experience and they can speed up the selection process. So I'm happy that we have those groups and I think they play a role, but at the end when it comes to the wider field, we need to teach beekeepers that they follow mite infestation levels. This is one of the biggest problems, that most beekeepers don't know about the infestation at the moment where they treat. And that has to be changed. So at the end, for the success in the whole population, the infestation levels are the crucial point. I think we can easily agree on this. But still, it can help if you have some breeders at place who do this extra work and institutes can support and all this. And if we want to come to successful genetic markers, of course it would speed up a lot. But okay, we come to this later on again, I'm pretty sure in the discussion, because we have some more questions which we would like to raise. Not to stop the discussion, all of you should have a chance, but I see the time is proceeding quite fast. And therefore, I would like to go one step further and we see which approaches are available, but obviously most of the beekeepers in Europe and in North America till now don't have resistance. We have with intensive chemical treatment. So the question is, why don't they have resistance? So probably most of them would like to have, and I'm pretty sure you come here to this round table because you are the ones who want to have resistance. So the key question is, what are the challenges? Why don't we have resistant stock? And here, maybe Johan, I would address you. You are an advisor, yes, working in the front, and you know beekeepers' reaction. So what are the problems?
I think the problems, the beekeepers are very, very difficult, and most beekeepers, I speak, it's for Germany, have not so many colonies. They are very difficult, for example, Canada. The average lies between 6 or 7 colonies per beekeepers, and many beekeepers do it not for honey, they do it for just for fun. And for the most beekeepers is enough, the colony has a queen. The quality of the queen, they're not so important. And if they have a queen of swarm, or re-queening, it's okay. But if there's should re-queening the queen with not so good quality, I said, no, I will not catch my queen. I cannot catch my queen. I find my queen not. This is the problem. You see the colony have a queen, and that's okay. And this is easier to do a treatment, as we say, okay, we look for a resistant queen. We have also this problem, the diagnosis from the varroa investigation. This is also a problem. I think perhaps only the half or less people or the beekeepers measure the varroa investigation. The other looks what's more to my neighbor. If my neighbor do a treatment, then must I also a treatment against varroa. This is the situation in the field. This is the biggest problem.
Very, very basic problems.
Very basic problems. And other problems, perhaps also, we have a high density of colonies. If you look for average 6 or 7 colonies per beekeepers, and if the field range from one colony, there finds nearly 100 to 150 further colonies. That means 10 to 15 beekeepers. And if one beekeeper do nothing, there come the queen or the varroa mites from this colonies, from this apiary to the other colonies. The reinvasion is now the last years, because of the climate changing, a bigger problem. The bees collecting in our region is mid of November, fly great distances. This is a big problem.
Okay. Still, there is someone next to you, Stefan Mandl. You run more than 10,000 colonies, and you told us you have 2,000 colonies under selection.
Yeah.
And you collect light samples, or you know about interest. How can you manage with so many colonies?
I have to start at the main problem we had. We worked the whole year a lot, you know, there's a lot of hives. It's really a lot of work, beekeeping. And at the end of the year, so at the end of the season, then it comes the overwintering, and we lost about 15 to 20% each winter. And this is the normal way of beekeeping. So this went 15 years, 20 years. And then once my wife saw this. So I could hide very, very well what we did in the period, but once he said, you lose 20% of 15,000, so 3,000 hives each winter. This is a huge amount of money. And she told me, I remember this, how is it possible that you are such an old beekeeper, but so a bad beekeeper? and then I thought, yeah, that's right, we do not earn so much money, so what we are losing in the winter time. And they had a big personal pressure, you see, and then I asked all my friends, my beekeeping friends, Ralph, and I see, or nearly all are here sitting, what are you doing against this? And the common sense was, you have to count mites, you have to establish a system, what is possible for you to count mites, and this is the reason. And our way now is, we make 3 times sugar, powder sugar. It's very easy, in July, August and September, and for 3 colonies, it needs only 5 minutes. So we have a good system. We have the sugar shaker, give bees inside, set a timer for 3 minutes, and make the second sugar shaker and the third from 3 colonies, and then the timer goes. We shake them 1 minute, right? Or 3 mites on 50 gram bees, and the second have 6 mites or something. So very easy and quick possibility to overview how many mites more or less you have in the hive in July, in August, and then in September. So it's about 5 minutes for 3 hives. So let's say 2 minutes for one hive, and this is no money. When you calculate, the professional beekeepers calculate how many time I need in a year for one beehive. For example, 2 hours. I have to manage 2 hours or pay 2 hours work for each hive, and then you calculate you need 3 times varroa controlling. These are 3 times 2 minutes. These are 6 minutes. So you have the most work you do already. So 95% of the work you are doing already, and only a short few minutes. It's not a hard work, it's a sweet work. So like for us beekeepers, it's okay. But and then you know who remains on a low level is the varroa mite. July and August and September. And who remains, this you select. We have the good thing that we are in bee breed, so it's a professional professional breeding value estimation with this, so it's easy to select it. And now we are doing this, I think, since 10 years. And the first few years we didn't see a big change, but now it's really good. So a lot of it's already 37% of the controlled colonies, where we know the pedigrees, where we make the performance testing, do not need any treatment. So they remain under the limit, under the Varroa limit of 2%. So this is our personal limit. So they are not allowed to go up to this 2%. And who remains under this 2% will not be treated. And when you do this few years, it's like my friend from Oslo told, it's easy. And this is the way we are doing. And I think in few years the Varroa mite is absolutely no problem. But I have one question. I have to please you. My wife will come today in the evening. Please do not tell her that's easy.
Thank you very much, Stefan. But still, one additional question directed to you. People told me that you are a good businessman, and selection costs money, and chemical drugs are cheap. So, is it really, from a commercial point of view, interesting for you to go for resistant stock?
Yeah, it's the only way. Who is not going for this in few years will not keep anymore. It's the only way.
Okay, beekeepers are lost within the next few years, Torsten. I come to you because you mentioned in the introduction that in Germany there is this project or initiative, Varroa 2033. So the idea that we might be free of any chemical treatments in general beekeeping. And we heard about the problems of beekeepers from Johann. How will you overcome this with the beekeepers in your association?
That's an interesting question. We must have education, and we must have teach multiplication. And we have very engaged beekeepers. Some of this are here, René, Tino, and other. And it is very important for us that we have small clubs, and they can count the mice and teach the beekeepers. And then we have 4 pillars in our project. The first is breeding, the second is education, the third is biotechnical methods, and the work, the press work is very important, that we must give the knowledge to the beekeepers. And I think it is very interesting, because bee healthy is necessary to have success. We can't say to the farmer, they must reduce plant protection substances, and we put every year new substances into our hives. It is not good. And the changing of ways with work, the work of beekeeping is very hard work for all of teachers of us. Confucius said, the longest way begin with the first step. I think in Germany we have made the first step, but we have engaged neighbors, Poland, Luxembourg, Switzerland, Austria. All the beekeepers will have healthy bees, and we must come to the goal that we not lost bees because they have a lot of mites. It is very important, and we must reduce chemical treatment. I hope that we can have beekeeping without treatment. I hope. But this goal we can get if we work together. With scientists, with beekeepers, with bees.
Okay. Thank you very much. So, we have heard some applause from the room. We are pleased. Maybe we don't see you very well, but maybe can you raise the hand? How many are not treating their bees? Okay, so I think we can say that is a minority. We have many more people who treat their bees regularly. I hope we have provoked some thoughts in you and maybe even some change in your attitude. Because you have heard some success stories on the stage here today. Maybe we have some fiascos as well, some people who haven't succeeded, some failures. So please comment on what we've heard so far. Maybe somebody has tried and said, "Oh, you are idiots, it doesn't work."
We take questions.
It's funny.
Okay. Yeah, you see it better from there. We really have a problem with the light. Please help us. Yeah.
I just had a question for Stephen Riley. I really enjoyed your book. I told Kara here that my wife's terrible dog destroyed it, so she's got me another copy lined up here. You can see in the earlier USDA fact sheets like Harbo, Harris, VIA, that uncapping is like the first visual indicator of VSH, and we see it in resistant populations. I see people that'll post, like they bought queens from me or someone that's selected for VSH, and they'll post pictures of bulb brood, and the internet comments from experienced beekeepers make me want to turn my phone off and go walk into my wildflower meadow for a while. Do you see the same issue with experienced beekeepers not recognizing exactly what bulb brood is? I know it's an education issue, but do you see the same thing where you're at?
Exactly, and thanks for all your work, Corey, as well. Fantastic job over there for you. Yes, bulb brood was something which was thought as a sort of minor issue for bees from our own national bee unit, and the recommendation was to requeen. No one quite knew what the problem was, but and which of course was exactly the worst thing to do. So bulb brood or uncapping is just an investigation phase, and that can be for varroa, whether it's in clusters, it can be in straight lines, for wax moth. So we know that bees do this already. They'll do it for sac brood virus as well, and chalk brood. So uncapping is just a normal part of their hygienic process, and it's experienced and long in the tooth beekeepers, or perhaps who have been the educators in the past, I think are still telling the story, but who are also treating and don't understand how varroa resistance works. So there's still a big challenge on the educational front there. I completely agree.
So did the microphone get to Fanny? No? You have the microphone, so just...
No. Thank you so much. So first of all, I think it was wrong to hold this workshop in this room. We needed a big room. Second,
you are the organizer.
I couldn't really know. It was just anyway. It's really valuable, all your contribution, and it seems that it is the time that we finally have a very good knowledge of what we should do. And I will start from what Torsten said. We have our bees, but let's talk about our local bees. We have our beekeepers. Let's talk about good, educated beekeepers. Then we have our institutions that they are doing all the research to back up the work and support the beekeepers. And then we go to the government. Because this, I didn't hear it yet. And I will tell you why I'm saying that. That the beekeeper needs to work with a good stock, the local stock, because otherwise a lot of money are going abroad from each country, like it's happening in my country, for example. And at the end, okay, some beekeepers are more devoted, so they can do their work with groups and they can do selection projects themselves. At least the minimum each beekeeper could do once per year to monitor the varroa levels. This is the minimum that each beekeeper should do, no matter if it's a backyard beekeeper or big professional beekeepers that, like we have in Mediterranean and in the south. And then, of course, we go to the institutions, but the institutions need money. needs project. And if there is no national project, breeding national projects in each European at least country, because now we are in Europe and my experience comes from there, we don't get anywhere. Because beekeepers in Greece, they move 7 times per year. 7 times per year, that means, and with a very high density of colonies, that means that whatever they do, their colonies will be reinfested. So at the end, of course, they are doing something, but they need something bigger. So local support, institutions, and government. And as part of Apimondia, I would like you all to support Apimondia on this and go to the European Parliament and send a letter to everybody, because something like a recommendation needs to come out of this workshop, not only we discuss and we exchange experience. To go to each government, to each ministry and say, look, this is the time to do it, because otherwise we are losing what we are doing. Research alone cannot be sustainable if there is no support. Can I have your support on this? Thank you.
Hello, thank you for asking that question that you proposed. Why are not more beekeepers keeping hygienic bees? In January, my name is Lisa Gezi. I'm from the state of Maryland in the United States. And I attended I'm a 16-year sideliner of a small operation of 50 colonies. I managed them all myself, very hands-on. And in January at ABF, American Beekeeping Federation Conference in Reno, I heard Dr. Marlo Spivak say the exact same question. So I took that question back to the state of Maryland. Given I am a citizen scientist, with respect to all scientists, my data set was probably not all ticked and tied perfectly, but it did give me some early indication. And I was amazed to find a high response rate. I might have a poster number 47 outside of 15% on a small group again. But 36% of those that responded did manage, not necessarily VSH bees, but a combination. It takes the whole colony. And two of my main findings were what's been said: education and people resistant to actually even testing for bees, as Johan here said. And in complicating that is if they are...
Can I just reply to that I'm not saying that it doesn't work. I think there's a really big, clear distinction between people just stopping to treat their bees and letting them be and trying to do treatment-free beekeeping, where you're actually involved in monitoring mites and selecting for low mite infestation and what we think might be resistant colonies. So I think that, I'm not trying to say that it doesn't work, but I think it's a bit of, I think there's a, and you brought this up too with these beekeepers that start beekeeping and after 3 years are gone. And I think it's become quite a trend to just think that natural selection is going to solve the problem on its own and we don't have to do anything. And I don't think that's the case. I think you have to be really, really, really meticulous and monitoring and making an effort and being well-educated beekeepers.
So we got even one question from the panel. So please.
Yeah, thank you to give me this opportunity again. Pierre asked a question. How many beekeepers here don't treat? I'm going to ask another question. I'm going to talk to the queen beaters that are here. How many queen beaters here can say that they can sell me a queen that will give me a colony that I do not have to treat anymore? So I want to buy 1,000 queens. Can you give me that? And then I don't have to treat. And you'll be responsible if I lose 80% of my colonies. No, that's the reality that we have.
Yeah, but it's...
It's our reality. We import over 300,000 queens in Canada each year. And in 2022, we lost 46% of our 800,000 queens in Canada. We don't even know exactly why, but if you ask beekeepers, it's the varroa mite. So that is our situation. So when I say I cannot, I really, my dream is to give green meters, wheel multipliers in Canada, a Varroa resistant stock. And I'm sorry, I cannot at this time. And I cannot because there's a lot of people here that are give advice to that are veterinarians. And if a beekeeper comes up to them and say, okay, I got Varroa mite, are you going to take the risk to say, well, come on, don't treat. Don't treat, that's the way to go. I have 1,500 colonies, and this is what my family lives from. Am I going to do that? No. No, I'll try. Me as a researcher, my goal is to work on the traits that Fanny has found. On the uncapping, recapping, trying to find a trait. I understand when you mention, you go to the 2%, we have the 3%, we all try to do that. But when you say that, in my head I say, well, what do you do with the ones that go over 2%? Pardon? Formic acid, so he treats. Okay, so that's the only thing, and the queen beaters, that's the solution here. And I know queen beaters, I see some from my country here, and they're the ones who are going to give us the stock. Because, okay, so I just wanted to say that, okay?
Okay. Direct answer by
The direct answer to this. Two things. We are not at the end of the way. So we have this one who are not able to resist against the Varroa. We have to give formic acid. We do not want to make it like in Gotland, to let them die. It's not necessary. So 37% of the population is possible not to treat, so they are able, and from this we are safe. Maybe next year we are at 50%, and it needs some years. And the next thing, it has no sense to hope you can buy resistant queens. So next year, next year, the daughter generation, they will already split up. So if you do not have a breeding program in your company to count the mites and do it yourself, it has absolutely no sense. You will stay on the same level like now. You have to do the work yours.
Okay, hello. Something from the corner over here. Yeah. Peter, Switzerland. I don't want to be a party spoiler, but I'm just asking, what about the dark side of the force? Post-parasite co-evolution is the fundamental framework we talk about. And sorry, you only talk about post-evolution. What about the mite side? In a resistant population, can we safely exclude that the mites are evolving as well? And another point is, mites are not killing colonies. It is the viruses they transmit. So instead of Varroa resistance, what about selecting for virus resistance? Sorry, two questions. What about the dark side of the force? And what about the role of virus resistance in the puzzle? Thank you.
Okay, for the dark side. So you're right. It is the virus that kills the colonies, and that's transmitted by the mites. But these mites have been around for hundreds of thousands of years in their natural host, Apis cerana. And what appears to be happening in Apis mellifera, they're doing exactly the same thing. So they're basically they're getting good at removing the mites, kept removing mites from worker brood. Don't seem to be really doing it from drone brood, which is a bit of a mystery, but that's just the way it is. And so there's been no co-evolution in the Apis cerana mites. They're happy, they're surviving, they're adapted to live in their drone brood, and their entire life cycle of the Varroa mite is basically they live a whole year. The females, they short reproductive burst in the drone brood, and they can't reproduce in the worker brood because the bees prevent that. The bees are happy, the mites are happy, both survive. And that seems to have got to a stable situation. And I believe that eventually this is the same thing will happen in Apis mellifera. Why I believe that is because we've got data from the 1990s when I first started working in Brazil and Mexico, when resistant colonies there had infestation levels in the worker brood of about 20%, which is very high, but colonies were resistant. And now, 20 years later, the levels of infestation of worker brood has been taken down to 4%. And it seems to sort of stabilise out around about that. I don't think there's any point in the bees eradicating the mites. It becomes way, way too difficult. So I think eventually what will happen in Apis mellifera is what's happened in Apis cerana, where you basically, that coevolution race stabilises out. And you have both the mites and, like all parasites, they're there at low levels. The bees will keep the numbers down, and both will survive. So that's my take on it. So it's not a dark side, it's just, yeah, it's a good news.
I can add to it as well with the Gotland population, because we've been looking a lot on the dark side of things. We see that we have samples of bees and mites over the 25 years of this population. So we've looked at mites and see that they have genetic structure changes over time. So there, we don't know exactly what kind of traits they're adapting with, but we know that there is some kind of change in their population genetics. We also have looked at virus infections, tolerance and resistance. So they survive with really high deformed wing virus levels when other colonies would die, other bees would die. We've looked at colony and also individual bees infection experiments. So both with deformed wing virus, they seem to tolerate really high levels, but other viruses like black queen cell virus and sackbrood virus, they're able to reduce over the season so that they have very low levels of these viruses going into winter. And we know that maybe they're not Varroa-associated viruses, but they're very important for spring health of the honeybee colony. So there's lots going on.
Yes. I think I'm the next. I want just to recommend what I missed in the discussion is we have with the roller tolerance also the drones play a big role. Only if the queen and the drone has the threats, it will be the next generation. And I think we have more also to get in focus how we scale up from the population we have. We selected to rural terrains, to mating sounds also locally, where we get also more of the behavior.
I think it's quite interesting that the philosophy of the beekeepers who were first out with the Varroa-resistant bees was not to share their queens to other regions. They experienced that when they sold their queens, it was not quite a success because of the philosophy. They cannot export the philosophy in the same way as the queens. And this is a problem I see with the small beekeeper communities in the Swedish countryside. It took about 15 years for the most of them to learn how to treat Varroa. And now they fear that they do something wrong if they change their behavior there. And this is very important to export the philosophy, and I'm quite glad that you are here today. And some more in the public here says that it's easy, and easy is relative. But just you can implement the philosophy. I guess it's much more easy, and you have you need some bravery to change your ways. But I guess most of us are ready to do this. And if you ask the old beekeepers, how was it in the 60s and 70s? It was wonderful, of course. And it was 1,000 kilos of honey in every hive. And you know, you can have on the horizon, you can tell your people, maybe we come to this kind of beekeeping again, if we all are ready to share the philosophy. Thank you.
Yeah.
Yeah.
Question?
Well, I might add to that. Martin Gabel from Germany. So I would like to try to bring all the statements together because I would say I agree with all of you, even though you sometimes disagree with each other, I think. I think we need a more inclusive or holistic approach. It's not whether treating or not, or live and let die in the strict sense, let's say, because we know this works. You showed this nicely in several untreated populations around the world and also managed populations. But we also heard the needs and the problems of Pierre, for example, or we have heard that some varroa-resistant populations suffer other problems like chalkroot. So why not implement these natural approaches into our beekeeping and adding value by selective breeding, for example, for chalkroot resistance or chalkroot tolerance, which we know works. So I think we need different approaches or different pillars, so to say, which we can bridge then. And education definitely is one of these pillars to bring all of these basic principles together. And in this sense, also what Peter said, this dark side would be implemented because, as we heard, it's more or less not a dark side, it's a black box. So also we would select for better mites if there is some sort of selection for better mites for beekeeping, let's say, or for bees. We don't need necessarily to know why they cope better, why the bees cope better with this kind of mites, but we should improve the stock in this sense. And I think this is also one of the core ideas or the spirit of this Varroa 2033 movement in Germany, as it was already said. And I would like to see this at a bigger scale, let's say, to bring this into our minds and have this spirit, and not to discuss whether to treat or not, but to see how can we implement bits and bytes which fit our personal way of beekeeping, our hive management, our under local conditions, and thereby also secure the diversity of colonies. Because I know, Pierre, for you it's difficult to breed queens or to raise local stock, but you're working on this. And for other regions, all over Europe, for example, it's more easy to keep locally adapted bees, let's say, and to keep a sustainable or self-sustaining population of bees. And we also should keep this in mind, not to promote the wide dispersal and crossing of resistant stock, which was selected under one condition in the whole broader beekeeping world, but to use this natural approach to really keep the broad base of bees and beekeeping at a resistant level, or to bring it to a resistant level and keep it also resilient to future challenges, for example, climate change or West Valentina or whatever.
I see a hand, but I have one comment. So Pierre said, can I buy queens somewhere? So I would like to ask you, next time you want to buy queens, you ask, do you have any varroa-resistant bees? Because I think the queen breeders do not know that there's a market for this. If you don't ask for it, if you just want to buy queens, you get queens. If you want to buy varroa-resistant bees, they will say, no, we don't have them. But maybe they will start to think, oh, we have to make some.
Are there any queen breeders that sell them?
Yes,
Yeah, one more.
Yeah.
One more.
Yeah, this is mostly a question for Stefan Mandl. For commercial beekeepers who have a method in place for monitoring mites, but they do need to maintain their survival, so they have to treat while they're transitioning to varroa-resistant bees. What kind of treatment strategies and methods have worked best for you in that transition?
We are trying not to treat, but the basic system is we are an organic beekeeping company, so we are limited in the chemicals. This is good, but we are using for the who reaches this 2% limit for raw mites and all colonies which are not in the performance testing. So we are only testing testing 2,000 from 15,000. So you have to see nearly the whole company is not under control. So at this 80% we are normal treating 2 times with varroa formic acid after the harvest, so first time after the harvest, and the second time 1 month later with formic acid. And in winter time, when they are free of brood, we make evaporation with oxalic acid. So this is the way, but the goal is that we make the performance testing not only with 2,000, but to rise it a little bit. Maybe next year we are already able to make 3,000, and the goal is that we make the performance testing in this easy way that we can control, that we can monitor the whole beehives, the whole bee yards. And then it's a very close way when that we are able to breed or to make honey only with resistant bees. So it will be, so maybe in 2 years when we meet in Dubai, or in 4 years when we meet in Germany, I can proudly say, and then my wife also will visit here, we are treatment free. So it's near, but and everybody is able to do this with his local stock. So this is a very important thing. So it's not that Canada is a problem from the climate. This is another problem, but this is very important. So it has no sense when you buy from me queens and then you are over the hill. And, in 2 or 3 years you lost everything. So if you have no system implemented to count easy and cheap the varroa mites, you will stay on that level. And this is very important. It's on you. It's not on the bees or on the mites. It's only on you. It's very easy. Thank you.
Are you open mating or AI with your queens?
Sorry?
Artificially?
Are your queens open mated or are you artificially inseminating them?
So you need four pillars. So you need to make performance testing. Then you need a breeding value estimation. In Europe, it's very easy. We have bee breed. This is very easy. Very important that it's not only the performance of this one colony, also how did the sisters, how did the aunts, the uncles, mothers, how did the ancestors. So you need a breeding value estimation, and then you need a selection. This is also a problem because the selection is on the breeding value, and the security of the breeding value depends on how much on how many colonies did you test. So if you have only 2 queens, one is better, okay, but the security of the breeding value is very low. So you have to test, if it is possible, a higher number, work together with colleagues, that you have more bee yards to make the testing, but the security of the breeding value is very important for the next, for the third pillar, to make the selection. So that you know this one is the better one, or this one is the better one. They need to produce honey, they need to be gentle, and they need to fight against the varroa. And so this is very important, that the third pillar to not make wrong decisions, which one will the breeding mother for the next year crafting. And the fourth is also very important, you have to make somehow more or less controlled mating. So in Austria, in beautiful Austria, we have mountains. We have only mountains. Not we have also very beautiful other things, but the mountains are very important for the controlled mating. So we have controlled mating stations, I think 15 or 14, and with different fathers. And the controlled mating, it's not necessary that it's 100%, but it should be more or less 90% that you know who is the selected father. And when you have a selected father and the selected mother, it's only a question of few years that you get in resistance.
Thanks.
Hi, my name is Artur and I'm coming from Warsaw, from Poland. We are focusing on the varroa resistance bees it's of course good. We are selecting like in a speed up Darwinian selection made by men to pick up best queens, to pick up best genes. However, this is one chase. The second chase, which is really simultaneous or somehow independent from us, but paradoxically dependent on us, it's Varroa resistance itself. So resistance of Varroa to chemicals, especially to synthetic chemicals. And this chase is speeding up. It's going faster than we want. For last 40 years, what we, Beekeeper Society, we did better was we selected Varroa to these chemicals. So I'm driving to the point that, as it was mentioned before, the education is not only to select best families resistant to Varroa, but also, paradoxically, teach beekeepers to treat well their families and not to speed up this selection against resistance, and especially to use organic acids, because Varroa is not resistant to chemicals like formic acid, oxalic acid. It's only resistant to bad treatment of made by synthetic chemicals. So I'm driving the second point of our goal of our education to teach, paradoxically, beekeepers good behavior in their apiaries, not to speed up the second ongoing process. Thank you.
Thank you very much. I'd like to come with a comment on this because we also want to move on in the program. So actually, according to the EU regulation, you have to count your mites before you treat them. And you have to count your mites again after you treat them. This is a law. Nobody is following it. But then you also have the law of nature. If you don't control your mites, if you don't check how many you have, you will lose your bees. So that's much more important than the EU regulation. So really, we need to change the mindset of the people that you just treat without ever knowing if there's anything to treat. This is very poor practice. So we need to do something about that.
So at that point, thank you very much for this great discussion and contributions from your side. We very much appreciate this. I think it's highly intense and interesting. But still, we have to keep the clock in mind, and it's 20 minutes left. We would like to raise a last core question, not to stop open contributions, and we will discuss it further on, but maybe it got very clear from what we discussed so far that the crucial point is beekeeper education. So these simple things which are missing, and internet with institutes, you all have your training schools and so what is missing and how can we improve this? And before we start with the whole auditorium, I would like to ask Steve Riley once again, because you are really the guy at the basis who somehow organized that. What do you think are the most crucial aspects of training, of information, of advice we should give to local beekeepers?
Yes, thank you. I think we need to talk about bee behaviours, and hygienic behaviours in particular, not about treatment-free. I think that treatment-free is something that occurs as a result of having bees which have sufficient Varroa-resistant traits. And it's understanding those traits. And we have found that all beekeepers are fascinated by these behaviours, as they are with all bee behaviours, particularly newer beekeepers. So it's a very easy subject to teach. We've worked with one of our 3 beekeeping groups in the UK called BIBA, BIPA members here about bee improvements, and they are actually championing grower resistance now, sending out emails, and there's a growing email list which you can join for regular updates on it. So that was a good change. There's also our education authority in the UK, the BBKA, have now included grower resistance in their what's called their modules. So it's one part of the education syllabus if you want to become a master beekeeper. It's something you have to understand now, which is really good news. Unfortunately, at the sort of the top of the education chain, our statutory authority on bees seem to be fighting the 1990s problem of Varroa. So there needs to be some movement there. But I think we've now got, or certainly just from a UK perspective, we've got people talking about this subject at just about every regional and national conference and normalising it in effect. I think the other area which is starting to move forward quite quickly is people working in club projects. So starting small, people who are keen, who come together, working in WhatsApp groups, understanding the traits, and then showing success, hopefully, to other beekeepers within the club. So clubs, regional clubs, are a perfect area for education and rolling things out naturally. And you will get to a stage where people will ask the right questions of bee suppliers. I think that's a really strong point, because selling non-resistant bees to unsuspecting beekeepers really must stop. And it's just a question of them and the bee suppliers understanding that. And I know they're very sensitive about it now because we have a much higher profile. And I think if we can do that in the different countries around Europe, and I'm not so familiar with North America, I think there seems to be a massive contribution of non-resistant queens being produced or imported, which is something which needs to be tackled at a different level. But it's understanding the key traits, I think that's the important thing. They're not so hard to understand. There is a level of complexity which our researchers all around me enjoy, but from the beekeeping perspective, observing those traits and making selection decisions on those traits is pretty straightforward. And we always say to people, look, if you've got really mean defensive bees, you're not going to brief on them, are you? And it's an obvious answer. And all we're doing here from the monitoring, which we recommend, is finding those bees that really cannot cope with Varroa. Those colonies which produce vast clouds of mites and associated levels of deformed wing virus is not something you want to select for. So it's people, the penny drops very quickly, I think, when you talk to people, and we just need to keep rolling out that education.
Okay, fine. So you mentioned annual meetings, local clubs, explain the right things, explain bee behavior. It sounds nice. But how many percent of the beekeepers in your region you can reach with these offers? How many are just out of the community?
There's been some work done on the amount of people who are now not treating in the UK. What's the number? About 25%, Stephen?
Yeah, 25%. That was 5 years ago.
Yeah. So there's been a lot of progress there. And maybe just as a little old island, we can do that. And the message is starting to get through. So they're starting to make progress. Okay. So within our club, we've got people who really want the Varroa-resistant bees, and so we've just set up a breeding apiary just to accelerate that, so that no one has to buy in bees, because all the bees you buy from our bee suppliers in the UK will be non-resistant. So we have to teach two things. One is Varroa-resistant traits, and then also how to raise your own queens, again in a very straightforward way.
Okay. So Johan, what are we doing wrong then? After 40 years of teaching, beekeepers don't know how to check for the mite infestation level.
I don't not think that we do was wrong. I think this is a changing in the beekeeping society. We have many beekeepers, they will not go to the clubs. They will not do bee advising. They will do their own thing. They look all perhaps for YouTube and other social medias. And if they are other than the normally advising, then they are attractive for these beekeepers. This is a problem. We reach only, I think, perhaps 50 to 70% only. And the others, we have no chance go to the beekeepers and say, do it so, or look it for the bees, or for the bites, or other things. That's a problem. They will do their own thing without a club, without an advisor, without another thing, and a regulator says it's not for them. There's a problem. I don't know the solution. It works since many decades, from years, and we think that the last solution.
I understand very well. This might be part of the problem, but still, I would like to resist there. If you reach 50% of the beekeepers, and you say, well, it's 5% who really count mice on their hives, so there's still a huge gap.
Yes.
Yeah, so.
I think that the young beekeepers that come to the clubs, that come to the trainings, they learned their count. And with these beekeepers can we discuss. They ring me and say, I have 5 mice per day. That's what they do. And this is not a problem. They can show what they can do. They can do treatment after investigation level. If they're below, then no treatment. This is not the problem. The problem is on the other beekeepers. And they must learn the problem for the other beekeepers in their own working to implement here.
So we have a problem with resistant beekeepers then.
Yes, yes. That's exactly advising the resistant beekeepers.
Okay, so thank you very much to all on the panel. But we have 10 minutes left. I would like to summarize a little bit at the end, but maybe we have 2, 3 more comments, final questions, remarks on education in specific.
So there's a few things I would like to say, but I would use a hive tool at my side by my wife if I said them all. Well, I'd like to go back to the comment of why not select for honey. And it reminded me of comments that Dr. Laidlaw, I had the privilege of studying under, said, select for industry. And that's what we need to do, is select for industry and select for other characteristics. But we need to select within a population, not individual colonies that we're trying to breed from. We're trying to select and have as many positive characteristics in our overall population. And if we are going to have a sustainable solution, it has to be an integrated pest management approach, where you have resistance to varroa, but you also use treatment when necessary. When you're making dollars, and it's your family that is dependent upon your bees, you need to treat. But you also need to be able to do for selection. Getting it back to education, I was a university extension specialist for a while, 30 years. I started beekeeping when I was 12 and I'm now 75, so I've been around a while. So when I give a talk to the general public and I say, if you're interested in saving the bees, for God's sakes, do not become a beekeeper. Plant flowers.
Yeah, so amen to that. Wonderful. Plant. I had a question, but it's not about education. Do you forgive me? Thank you. So if we are selecting for, I'm a queen breeder selecting for VSH, so I'm talking to myself now. If we are selecting for VSH and we done, Stefan Mandl did it, Paul Jungels, lots of people do it, but I think we should not do away all these wonderful queens that are not VSH, because we don't know what genetics are in there that we need over 5 years or over 10 years when some other threat comes to us. How do you think about that? And now I'm looking to the both Steves to answer that.
All our bees are open matrix, so we have all of the diversities that bees are intended to have. So they should be able to cope with anything new that's coming along in due course, fingers crossed. So the issues will be where people are very narrowly mating the queens.
Yeah, I would agree. We seem to have a lot of success with just open mating. I think you're speeding up the process. The bees will get there eventually, but you may not be wanting to wait 10 or 20 years for that particular line to develop the resistance, where by doing some sort of selection, and I am not for just stopping treatment, I'm actually for transitioning. But basically, by doing the selection that people like Steve's done and other people, is you're speeding up getting to that point. We know in feral populations where selection is actually brutal. Eventually, 1 or 2 colonies which survive through that, the vast majority of them actually die. But again, because you've got this huge genetic variability, I believe personally that beekeepers worry too much about the genetics. All social insects, including honeybees, have this amazing ability to recombine the genome, generate huge amounts of genetic diversity from next to nothing. Tom Seeley's studies have really nicely, Dave Peck's studies really nicely shown this. So the bees, again, they have these amazing adaptive abilities to retain this huge amount of genetic variability. So I wouldn't worry too much about it. Select for what you want, and you speed up. And I know beekeepers don't like to get rid of queens. It's like it's some sort of innate thing. But if you had somebody had a really bad disease like Ebola, you wouldn't treat them in the middle of a huge music festival, would you? You would isolate these people, and that's what modern beekeeping often does with the almond pollinations. You take sick colonies, put them with thousands of other sick colonies, and wonder why you've got real problems. Unfortunately, it's better to sacrifice some of the ones that are not what you want at that particular time. But don't worry about genetic diversity. That will recover through the drugs.
Okay. Thank you very much.
Okay.
So the time is gone.
It's
But there's
gone.
one man standing up there who
Who's
is famous.
for 20 minutes.
Usually don't speak below 10 minutes, but please, John, 1 minute for you.
Okay. So you can all leave. A little bit of advice: commercial beekeepers selecting queen breeders is when you're running a program, consider all the economic aspects, how much it costs you to select for your queens. For instance, in Chile, we tested 500 colonies for pollen production, hygienic behavior, and raw. And we found out that we chose out from that group 22 queens for breeder queens. And it took us a total of about 3.5 hours to test for pollen production, and 7.6 hours to test for disease resistance and all that. And once you have hard data that you can go on, then you can say, is it worth it for me to invest in the queen production selection? And then also you have to realize that when you're calculating the value of selection, if you have a queen that doesn't have varroa mites, then you're not going to have any varroa damage on those colonies between your next treatments. And of course, you might run into the same problem that we run into now with our breeding program, is that we don't have enough mites, and so we have to buy mites. And so this is the bad side of the program. And last thing is that we're talking a little bit about genetic variability in the mites. They did some studies on our colonies, and they kind of showed that we have a lot of genetic variability in our mites, whereas if you're treating your mites, you're lowering your genetic variability and probably selecting for resistance. Okay, I'll let you escape.
Thank Stefan. Many thanks. Many thanks to all of you. I really enjoyed the discussion. I hope we take something home from this. I was asked, can we shortly summarize? And I will do it from my perspective, but afterwards we can discuss it in the group and make it more complete. So I think it got very clear. Resistance is there. Resistance is a realistic breeding goal. And maybe we have to turn around the question. So far, beekeepers always ask, when do we get resistant stock? I mean, it's a phenomenon that after 30, 40 years of varroa in our countries, we still have susceptible stock. If we see on the other side that nature can solve the problem within a few generations. So this is really the phenomenon. And I mean, there's no doubt it has something to do with the way how we keep our bees and how we treat them. So we have a problem with our treatments. Natural selection is effective, but still it can't be a good advice to say just simply stop treatment. We discussed this and it was very obvious. And I'm grateful that we had several contributions which pointed out we need a more inclusive approach. I think Martin used this term, but others added to this integrated concept. And what we heard from the strategy followed with this varroa resistance 2033 is that there are several things to regard. For sure, we need the breeders. They have to select. They have to do all this what Stefan Mandl described. So performance testing, breeding value estimation, careful selection, use mating stations or controlled mating to speed up the process. But at the end, it's not the breeders. They can support, they can supply good basic material, but it's more than on the local basis that beekeepers have to react. And then we came to this very important point that obviously we are missing some points in the beekeeper education or beekeeper training. And I think this is a take-home message that we have to get better. Very interesting for me to hear what Steve recommended. Teach them about bee biology, better understand what our beloved animals can do if we let them live and get motivation out of this. So I think at the end it gets clear it's a realistic goal. We can say yes, we want to be treatment free, but we need a good strategy for this change. And this has to include the breeders, the institutes, but most of all the beekeepers in the wider field. We have to motivate them, we have to train them, we have to help each other. The knowledge is there, we have to share it. And in this sense, many thanks, Fanny, that you joined the discussion here and you said the room should have been bigger. I hope next Apimondia we get a much bigger room for the exchange on this and make progress till then. But you raised the point that you said maybe we should have some recommendations in the sense of we can put together what we discussed here and what we learned from each other. Recommendations which can, via Apimondia, then spread out to governments. We need political support and we need beekeeper associations to pick up the thing and say, yes, that's where we want to go. We have a clear goal and the future in beekeeping must be with resistant bees. We can't go on with this high dependence on all the drugs. Specifically, I think Torsten, you mentioned this, if we want farmers to reduce pesticide use, all those things, we proclaim that we have problems with the environment, then we have to be the first to show that there are alternative ways which are more nature-like management and which can strengthen the natural vitality of honeybees. So I think that's the way. Hopefully we can proceed on this, and I take John at the end your aspect. I think it's a good goal. time we should all pay for mics, that we can further on study this interesting relation. And with this, we are closing this workshop. We hopefully have time to meet in smaller groups and go further on. Thanks once again to the panel. I think really made a great job.